Hello, everyone. A very good morning, afternoon, or evening to you, depending on where you're logging in from. And welcome to WIT's very first upskill workshop for 2024. My name is Manogna Mantri Pragata. I'm a senior data scientist at Slalom, and I'm delighted to be a host today. So today's workshop is hosted by Keiko Kamei. Keiko is an analytics scientist within the scores and predictive analytics team at FICO. She joined the team shortly after graduating from UC Berkeley in 2019 and with a degree in applied mathematics with a concentration in data science. At Berkeley, she led developer teams to integrate data science modules into curricula that traditionally did not offer hands on data science opportunities, like legal studies or social inequalities. At FICO, she supports the research and analytic development of the flagship FICO scores, as well as new scoring solutions that leverage alternative data and promote financial inclusion. What Kiko loves about data science, beyond its elegance, power, and endless creative applications, is a supportive community of brilliant and diverse minds it can bring together, like those she has been so fortunate to be a part of at Berkeley, FICO, and WITS. So Kiko's workshop is titled From Couch to Jupyter, a beginner's guide to data science tools and concepts. She has a lot to cover and hence would take all the questions towards the end of the session, but please feel free to put your questions in the Q&A section. Kiko, over to you.
Awesome. Thank you so much, Manogna. And hi, everyone. My name is Keiko Kamei. I am an analytics scientist at FICO on the Scores Predictive Analytics team, and we are responsible for the maintenance and development of our flagship FICO scores in the US and in Canada. At FICO, I get to work a lot with credit bureau data, but I also get to work a lot with what we call alternative data. And with alternative data solutions, the motivation is really to enhance financial inclusion. And we can do that by layering the consumer permissioned alternative data on top of the traditional credit bureau information. So to give us more insight into the consumer's risk and to enable greater credit access to consumers who may not have a very rich history in the traditional credit space. So that's a little bit more about what I do. And speaking of financial inclusion, this workshop is inspired by one of the motivations behind the WITS Datathon, which is currently ongoing. And that motivation is to enable data science enthusiasts from all backgrounds to participate in the Datathon. So we wanted to make sure to provide some materials to help build that knowledge from the ground up. This GitHub repository contains some of those materials. They cover a range of topics from intro to Jupyter and intro to Python to data structures to how to work with statistical concepts. And today's workshop notebook is also contained in this GitHub repository. And it references the other tutorial notebooks, so feel free to reference those on your own time to continue your learning. But in order to access these interactive notebooks, we have to have a platform to host the Jupyter Notebooks and to run them. So we have this Anaconda installation guide on the website here that you can reference to help you install Anaconda and also to download this repository onto your computer so that you have access to the interactive notebooks. So we like Anaconda because with Anaconda, you also install Jupyter and you install a whole bunch of other really useful data science packages. And also Anaconda allows you to really closely manage what are called virtual environments, which are covered in the Anaconda installation guide. But at a high level, virtual environments allow you to install different versions of packages. Because sometimes different projects require that you have different versions that you use, and also different packages require different versions of other packages for it to help run. So to prevent conflicts from arising from installing different versions and crashing your root installation, it's best practice to create and use virtual environments. And you can learn more about that again on the Anaconda installation guide. So there are two ways to navigate Anaconda. You can use the Anaconda Navigator, which is a graphical user interface, or you can use the command line. On Windows, it's called the Anaconda prompt, and on Mac or Linux, it's called the terminal. So let me just open my Anaconda prompt and take you through how I would open my Jupyter Notebook. Okay. So here's my Anaconda prompt. It's pointing me to my user directory on my C drive. So this is a directory that you can find on your file system. And it's saying that I'm in my base environment. So I don't have any virtual environments activated yet. So let me go ahead and activate my virtual environment. So I have one called WIDS, and now it's telling me that I'm in my WIDS environment. So from here, I can launch my Jupyter Notebook. And what this will do is it will launch my default browser, which is Chrome. And I have access to, from there, I have access to all of my files in that user directory that we were just in, but now on Jupyter Notebook. So I have this WIDS demo folder that contains the downloaded copy of the WIDS Datathon tutorials repo. So I will go in there, and now you can see all of my interactive notebooks that I've downloaded, and also you have access to the data that we'll be using in these notebooks. So how to download these again, that's covered in the Anaconda installation guide. Let's go into the workshop notebook. All right, so welcome to the Jupyter Notebook. These are the topics that we'll try to cover today in the next 40 minutes or so. There are details in these notebooks that I'm not going to be able to cover in this workshop, but I wanted to err on the side of providing more information than I might be able to cover, so you have the supplemental information at your fingertips for when you're going through this workbook on your own. So the purpose of this workshop is not to go super in-depth in any one topic, but to cover as much ground as we possibly can. So to give you kind of a map and the gear that you would need to navigate by yourself some of these topics that you should know about. So let's see how much you can get through today. A great place to start is to know how to use the Jupyter Notebook. So a Jupyter Notebook is comprised of what are called cells. There are two types of cells. There are markdown cells like this one, and there are code cells like this one. Markdown cells are cells that contain text. If you double click into this, you can expose what is called a markdown language. And the markdown language allows you to format the text so that it looks nice when it's rendered. This is a code cell, and code cells take Python expressions. Expressions are just instructions that you give Python to execute. So in this case, we're saying that we want to use the built-in function print to print the content of this function. And we're feeding it what to print. We're saying we want to print this string of characters that say hello world. So to run cells, you can either hit Shift Enter or Control Enter. If you hit Shift Enter, it will run the cell and it will highlight the next cell. If you hit Control Enter, it'll run the cell and stay on the same cell. So again, this print function printed hello world, and you might notice that there is this line here that's commented out, and it doesn't impact the code at all. This is called comment, and whatever you put on the right side of a pound sign is just a comment. It's somewhere you can write notes, where you can help yourself debug, document things in line with your code. And again, it doesn't impact your code at all. So you'll see a lot of this throughout the notebook. All right, so we mentioned that when you install Anaconda, you install a whole bunch of Jupyter data science packages. And some of those packages are listed here, and the sites for each of them I've linked on here. But when you want to use these packages, you have to tell Jupyter that you want to access these packages. It won't know inherently what they are because these are external resources. However, Jupyter does know some things like built-in Python objects. So if you say to Jupyter, what is this built-in Python object max? Jupyter will say, I know what that is. That is a built-in Python function max. That takes the maximum value of whatever you put inside of it. But if you say to Jupyter, well, do you know what Pandas is? It'll say, I don't know what that is. You haven't told me what that is yet. So we have to point Jupyter to Pandas. And we do that by importing the Pandas package into the notebook. So we do this with an import statement like so, and we're saying as PD here, so we can store the Pandas library into this abbreviated variable that we can reference later on. So now if we run this, we import the Pandas library into the notebook, and now Jupyter knows that PD contains our library that's pulled from our installation site. Just like you need to point Jupyter to packages, you also need to point Jupyter to data files you want to read into your notebook. So here is a path that we use to point Jupyter to the location of our data file. Paths are covered in the third tutorial notebook, but at a high level, this is saying in the same directory as this current notebook that we're in, there is a data folder. And in that data folder, there is a CSV that contains our data set. So this is essentially instructions or directions of how to find our data file. We can use Pandas readCSV function to point it to the data set and turn it into a Pandas data frame. So this evaluates to a Pandas data frame object, which is just a two-dimensional representation of the data set that has rows and columns. And it gets set to this variable called df. And variables are just containers that you can name and to tell to store whatever you want it to store. So in this case, we're telling df to store our data frame. So here we're saying we want to show the content of df. So we read it in, we set it to df, and we're showing the content of df here. So this is the data set that we'll be working with in this notebook. So let's take a look at some of the data types and values that are contained in that data set. The file was downloaded from Kaggle. It's the stroke prediction data set. And there is a data dictionary that you can reference that's available on the Kaggle site that tell you what the columns mean and what some of the values contained in the columns might represent. Don't worry about what this is doing here, but essentially we're just showing the first 15 rows of the data set. So let's take a look at the content of the data. At first glance, you might notice that there are numbers and there are textual values that look like labels. So your first intuition might be to think, okay, there must be kind of two basic categories of data, numeric data and categorical data. And that's a good start, but not complete. So let's take a look at this really nice diagram that I found on one of the presentations done by the WITS Trinidad and Tobago team. And here we can see that there are two main types of data. There is quantitative data and there is qualitative data. Quantitative data is data that measure or quantify something, whereas qualitative data are descriptions or observations about something that don't numerically quantify anything. So if we look at our data set, we can notice that the age column, the body mass index column, the average glucose level column, these are all measurements about a patient. And so these are quantitative fields. And the other fields like smoking status, whether or not the patient has ever been married, and the patient's gender, these are qualitative pieces of information. Now you might notice these two columns here, hypertension and heart disease. These indicate whether the patient has hypertension or not, and whether the patient has heart disease or not. Ones indicate that yes, they do, and zeros indicate that no, they don't. So you might realize that this captures the same kind of information that's captured in this ever married column that indicate whether the patient has ever been married or not. So ones can be represented by yeses and zeros by nos. And so this tells us that these two columns are qualitative data, not quantitative. So the takeaway here is that even though data can be represented by numbers, they might not be quantitative data by default. Numeric doesn't equal quantitative. And that's important to know, the distinction between the different possible values and data types, because it determines how you might wrangle them, how you might visualize them, and ultimately how you process them so that you can feed them into a model. So in that light, let's take a look at two numeric values that you should know about: integers and floats. So integers, like this value 2024, are negative or positive, non-decimal whole values. So here you can see that Python understands that this is a value first and foremost, and that it doesn't have a decimal value after it. It knows that it's an integer. You can use this built-in function called type to check the value type of a value. So here we're putting in the 2024 value and checking the type of it. On the other hand, floats are numbers that have decimal values on it. So if you just add a decimal point to the integer value that we were just looking at, Python recognizes that as having a decimal point. It'll find that it's a value 2024.0. If you ask Python what the type of 2024.0 is, it'll tell you that it's a float. And it's important to know the difference between integers and floats because first and foremost, floats can represent continuous data because continuous data can take on any value within a range. So it can be fractions of values that integers can't represent. But beyond that, there are different functions, Python functions and other package functions that will not work on both types. So depending on the function, sometimes it'll only accept integers, sometimes it'll only accept floats, or it might behave differently based on what you feed it. So it's just important to know that these two types of values exist and that they're considered different by Python. Okay, really quickly, let's look at some arithmetic operations we can do using numbers. So you can treat Python code cells like calculators, and you can use these very familiar operators to add, divide, or to compute longer expressions. And just like we learned in grade school, the order of operation matters. So we'll follow Pandas in this example. If you take away, for example, the parentheses, it'll compute a completely different number. More interestingly, perhaps, are function calls. So we've already seen some examples of functions, like the print function to print hello world, the type function to check the type of things, and the read CSV function to read in the data file that we pointed to. So functions are really just operations that we give a name to, so we can use them over and over again very easily. And functions take what are called arguments. So arguments are really pieces of information that you give to the function so that it knows how to compute. So for example, if we look at a simple absolute value function that's built into Python, we first evaluate the content, what's inside of the argument. So this evaluates to -8, and the absolute value sees the value -8 and says this evaluates to 8. We can also put in multiple arguments into a function. This will round 5/3 to the third to 3 decimal places, like so. And if you're not sure what a function does, you can just put a question mark next to the function name without the parentheses, and Jupyter will pop up this doc string that tells you how to use the function and what it does. You can also define your own functions. That's a very big part of Python, but we don't need to in this workshop. So I'll just point you to the Intro to Jupyter Notebook to learn more about it there. Strings are another type of value. We've seen strings already. We saw a string that said hello world earlier in this notebook. So we can capture strings using a single quote like this, or a double quote, like so. And even though this value captures a number inside of the quotes, if you ask Python what the type of this value is, because it's contained in quotes, it'll know that it's a string. Strings can also capture longer pieces of text, and if you use double quotes, you can include single quotes inside the broader string. Okay. I'll let you read through this on your own as supplemental information. But let's go over some operations you can conduct on strings. So if you look at this addition, you might think that this will output string value 6. But because strings are completely different values than numbers, it'll compute differently. It'll just take the pieces of the strings and sew it together into one long piece of string. If we multiply a string by a number, it adds the value to itself that number of times. So this will just create a string of 10 ones. Here are some examples of string manipulation that you can do when you set strings to variables to create longer pieces of strings. And another one that incorporates both of the operations that we saw earlier. So strings have what are called methods. Methods are similar to functions in that it operates something. But methods are different from functions in that functions take in arguments that it needs to receive information about the operation that you're doing. Methods can also take arguments, but it also gets information from the object from which it is being called. So methods are denoted by a dot notation following an object. Here is a string object, hello world. We're using a dot notation here and calling this upper method on the string. And what it does is it says, okay, we have this information, we have this string, and we want to create an uppercase version of this string value. And so that's what it will compute. And like I said, we can also provide arguments into methods. So this string method is going to replace every instance of else in this string object with os to produce a strange word like this. And so we'll see methods throughout this notebook, in the context especially of Pandas data frames and series. These data structures have a lot of really useful methods that allow you to manipulate the data very efficiently and easily. Another type of data value is one that represents no data. So there isn't a one value that represents missing data in data files, but one that Pandas is able to kind of infer from data sets is a NaN value. So if you take a look at an image of what the data looks like in Excel, if you were to just open our stroke prediction data set in Excel, this is what you would see. You would see that in the BMI column, there are mostly numbers, but there are also these NA values that are clearly not floats that we would see otherwise. And so when we read in the data set, Pandas knows that, okay, well, this column should mostly contain float values, but there are these non-numbers that also show up. So these must be missing values. So it converts these NA values to NaN values. That is short for not a number. So here, when we open or show the first 10 rows of our data frame, we can see that the conversion has taken place here. Don't worry about what this is doing here for now, but we are just pulling out this particular NaN value from the BMI column of the data set. So you can see when we run this that Pandas knows that this is a NaN value, and that's a separate kind of value than anything else we've seen so far. If you just put this entire expression into the type function, it'll evaluate this to the NaN value, and we can check the type of the NaN value. And Python will tell us that it's a float value. So NaNs are floats. So it's nice when we can see NaN values in the data set, because that's an easy way to identify missing values. But it's important to understand the data very well and to know what other values might represent missing values. So in the smoking status column, there are these values called unknown. And in the data dictionary, there's a note that says unknowns are indicative of patients for whom the smoking status is not available. So these can also be considered as missing data, and we would want to investigate into them as part of our missing data analysis. There's a whole topic on null value handling. It's a very important part of data wrangling and cleaning. Before you feed something into a model, it's really important to take care of these missing values and either to get rid of them or to impute them so that you fill it with something like prediction of what that value might have been. And there are a lot of resources in the links down below that you can reference to see how you might be able to impute those values. And there's one small example at the bottom of this notebook that hopefully we can get to. That'll show an example of a very simple way to impute a missing value. Okay, so here we cover Booleans. So Booleans are another type of value. They can take, it takes one of two forms, true or false values. So whereas strings and numbers, they can have infinitely many values, Booleans just have two. So here we can see that Python recognizes true and false values. And if you ask Python what the type of the truth value is, it'll know that it's a Boolean. Note that it's case sensitive though, so if you just ask Python what true is, lowercase t, it won't know what it is. So make sure that the T in the F is capitalized. So Booleans are at the heart of what is called conditional logic. And this is also a really important part of Python, but we don't need it in this workshop. So I'm going to point you to the Intro to Jupyter notebook to explore this further. But we will cover Boolean expressions. So Booleans come up when you're asking Python if something is true or not. And one way to do that is to compare different values together. So we can compare the values 10 and 1 and ask, is 10 greater than 1? Python will say, yes, that is the case. If we ask, is 10 equal to 1, using the double equal sign notation, it'll say, no, that is not the case. So here are some operators that you can use. We saw the double equal sign. If you want to say not equal to, you would use the exclamation point and equal sign, and some others that are more intuitive here. And Booleans, we'll come back to this at the end of this workshop, but they're essential in filtering data sets. So there's an application at the bottom there where we'll use Booleans to manipulate some Pandas data frames. Okay, now on to the fun stuff. So now that we have kind of taken a look at some data values, we can look at how we can store them and organize them into structures. So there are different types of structures that you can use. There are lists, tuples, arrays, dictionaries, matrices, and Pandas series and data frames. A lot of these are covered in the other tutorial notebooks, but here we'll just cover arrays and the Pandas series and data frames. So let's start with arrays. An array is an ordered collection of a finite number of values of the same data type. So here's an example of an array. It has a finite number of values. It doesn't go on forever. It's an ordered collection, so each of these values has a position in the array, and we'll get to that in a little bit. And the values are all integers. They're of all the same data type. And the standard package to use for displaying and using arrays is NumPy. So we'll import NumPy as NP, so we can reference them as NP. And we can now use the array function from NumPy to turn this list of values into an array. So if we run this, we can see that it produces the same array that we see up here. You can also create arrays by using NumPy functions. So here it creates a longer list or a longer array of values. I'm not going to cover this now in the interest of time, but feel free to take a look at this. It's really useful for when you have kind of a structure and how you want to create the arrays. So, and you don't have to, by using these functions, manually input the values yourself. So if you try to create an array with different value types, like this one, we're trying to create one with integers and floats, what Python will do is it'll just turn the integer values into float types so that everything is consistent. And here, if we try to create an array with strings and numbers, it'll turn everything into strings so to keep it consistent. Okay, so once we have an array of values, a collection of values, we can look at ways to look at the distribution of those values. So let's make an array of our age column from the data set and set it equal to this age array variable. Okay, so now this array contains our age data. We can find the median of the array by using the NumPy function median. We can also find the age or the mean of the age array by using the mean method on the array. And also we can find the standard deviation. And all of these statistics we cover in more depth in the second tutorial notebook. So if you're interested in learning about those statistics, go to that notebook. But what happens if you try to compute a statistic off of data with missing values is that it will compute to a NaN value. So this BMI value column has NaN values, and you can't do math with not a number values. So this is one of the ways in which we can see it's really important to handle missing data because it'll compute kind of nonsensical statistics like this if you try to use data with missing values. So operations with arrays are very efficient. If we want to subtract a value from every value in an array, all we have to do is to subtract that scalar value from the array. And what it'll do is it'll subtract that value from every single element that's contained in the array. Here's an example of that in action. We're using our age array that we created earlier, and we're subtracting the mean from all the values in the array to come out with something called the deviations from the average. And that's a calculation that we need as part of calculating the standard deviation. Again, that's covered in the second tutorial notebook. If you want to add two different arrays together, what this will do is it will create an array that contains the sum of the values in the same positions across the two arrays. And also, if we want to find the truth value of the content in an array, we can do that using this Boolean expression. And this will tell you, in this example, whether the value in the age array is less than 70 or not. Okay. So if we want to extract values from arrays, we have to specify the position of the value that we want to extract from the array. And those positions are indices, are captured as indices of the array. And in Python, the index starts at 0. So the first value contained in the array is at index 0. The second value in the array is at index 1, and so on. So if we want to extract this second value from the array, we have to specify that we want to extract this value associated with the first index of the array. So this tells you the position of each of the values that's contained in this ordered list of numbers. So we can do this using a square bracket notation. We can pull out the value 61.0 from the age array. If you look at a data frame of our data and look at the age column, we can see that the second value associated with this first index is in fact 61.0. If you want to extract multiple values from the array, we do it a similar way. We have to specify the indices of those values we want to pull out. But instead of just specifying one value, we specify a range of values. So here we're saying, if you look at the first 6 rows of the data, here we're saying let's start at the 0th index and pull out every single index after that until we reach the 5th index, but don't include the 5th index. So this is going to create a subarray of these 5 elements that are captured by this specification. So this is indexing and slicing NumPy arrays, but this also works the same way for Pandas data frames and series objects. But for those, we have to use this ilog attribute, and we'll cover that in a little bit in the next section. So we've already seen what a Pandas data frame looks like. We've seen that it's a 2-dimensional representation of the data that has rows and it has columns. And it has a whole bunch of really useful attributes and methods that make it really easy to pull out information from the data frame and also to manipulate the data frame. So I mentioned that there are attributes and methods about a Pandas data frame. And an attribute is similar to methods in that you call it using a dot notation on the object, but instead of computing something from it, it's really just showing you a stored kind of information about that object. So for example, the data frame has this columns attribute. In the columns attribute, we can look at the information stored in this by putting in dot columns after the data frame, and it will display a list of the columns that are contained in the data frame. So notice that we don't have a parentheses after the columns instruction here. That's because we're not running any sort of operation that a method or a function would run. Okay, and here's another attribute from a data frame that we can pull, and this displays the number of rows and number of columns that is available on the data set. Here are some cool methods. The describe method calculates some summary statistics on all of the numerical features on the data. Notice how I said numerical and not quantitative, because Pandas data frames doesn't know the difference in qualitative versus quantitative. It just knows whether the values are numeric or not. And we can also use a drop function. This is just another example of a method in which you specify the column that you want to drop from the data set. and the axis, so whether it's a row or a column name. And it'll create a new data frame with this column or this name dropped from the axis that you specify. So if we want to pull out a column from the data set, you can do so with this square bracket notation specifying the name of the column. If we do this, we see something like this. This is called a Pandas series, and it's very similar to NumPy arrays. It behaves very similarly, and you can use it in most NumPy functions. But it has some very nuanced differences, like the attributes and methods that are available on the Pandas series object compared to the NumPy array. So some of these attributes are dtype that tell you the type of the data contained in the series. Has nans attribute that tell you whether or not the column contains nan values. And there are also cool methods. So we can use the asType method to create a new series that contains the same information as this column from the data frame, but stored as string values instead of the previous integer values. There's also this isNA method, which is really useful for finding nan values. This tells you whether the value in the column is a nan value or not. And a couple more really commonly used ones are unique method that tell you the unique values that are contained in the data column. And lastly, the value counts method tell you the frequency of those values found in that column. Okay, so we can not only pull out the series representing columns from data sets, but we can also create new columns on the data set by creating a new series on that data frame. So here we have this data frame object, and we're creating a new column called archive year. And we're setting this series to capture the values contained in this NumPy array. So if the data set was representing data captured in the year of 2024, we want to specify that in the data set. So we can create a NumPy array using this repeat function. This will repeat this particular value, 2024, this number of times. And this is specifying the length of the data set. So when we do this, the data frame now has this archive year column that contain that array of 2024 as the value. Here's another way in which you can create a new column. I'll let you kind of explore that on your own. This just uses the same content that we have learned already, the asType methods and element-wise operations on arrays. And so I'll let you explore that on your own. But I wanted to make sure we cover indexing and slicing using Pandas data frames in series. So in order to extract values from Pandas data frames in series, I mentioned that it's very similar to extracting values from NumPy arrays. Except now we have to use this iloc attribute. And this iloc stands for index location. So same concept as using the index location of values in NumPy arrays. We're specifying the index location of values in a Pandas series or a Pandas data frame. So here we have the age column represented as a Pandas series, and we're using the iloc attribute in the same square bracket notation, specifying the index location of the value that we want to extract. And we're extracting that same 61.0 value that we found on the data frame earlier, this second value in the age column associated with the first index. if we want to pull out a subseries representing multiple data values, we can use the same slicing notation as we saw earlier, using the same ilog attribute. We're specifying that we want to start at this 0th index and capture all the subsequent indices up until we reach the 5th position. So this will create a new Pandas series that contains just those 5 values. And finally, with Pandas data frames, we not only provide the indices for the rows, but also for the columns, because again, data frames are two-dimensional. It has rows and columns. So if we specify that we want to capture the first 5 rows, we can see from earlier that we would capture these 5 values. And if we specify on the right-hand side of this square bracket notation, we can pull out and specify to pull out the first 5 columns found on the data set starting from the left. So what this will produce is a slice of the data frame that contains just this upper left quadrant of the data. And just a small detail here, I don't have to specify 0 here, because if I don't specify a number on the left or the right side of the colon, it'll just take you all the way to the left or to the right of the possible values available on that object. Okay, so I see we're at 8:49. I'm going to, at least Pacific time, I'm going to blitz through what you can kind of take a look at on your own. But this is the very end of the notebook. So this is putting everything together and showing you what you can do with everything that we've learned so far in this notebook. So we said that Boolean values are useful for filtering data sets. So here we can use this comparison expression to create a series that show us whether or not the smoking status is an unknown value or not, right? And if you see up here, right here, we have an unknown value. And so for that value only, what's displayed, we have a true value. And we can slap on this series of true and false values onto a data frame and create a subset that contain only the unknown values in the data set. And so this is a really useful way to explore the data. Don't worry about what's happening here. But essentially, when you split out kind of segments of the data, you can do profiling analyses on them. So here what I've done is I've filtered for unknowns, I've filtered for knowns, and I'm comparing the distribution of age, the age of the patients on the same plot. So this is one way you can dig into kind of do some exploratory data analysis. Filtering also lets you drop columns, just like you can select columns. You can also just like you can select rows from the data set, you can drop rows from the data set by selecting the ones that you want to keep and not selecting the ones that you don't want to keep. And then finally, we can put everything we learned together to conduct some very simple null value handling. So here we can identify how many null values are in the BMI column by filtering for the BMI, the NAM values in the BMI column from the data set, and then finding the length of that data set. So there are 201 NAM values in the BMI column. And if we want to replace those NAM values, we can use this fill_NA method on the series. And essentially, you can go through the steps here, but we can find the median value of the records that are not NAM values in the BMI column. And then you can use this fill_NA method to populate those NAM values with that median value that we calculated as a very simple approximation of what those NAM values could have been in the data set. And if we set it to the original BMI column here, we have that the NAM values that were here before are not now populated by the median values that we've just calculated. Okay, so I've gone way over the time that I was supposed to talk. So here are some additional resources that you have access to continue your learning journey. And I'll turn it back to Manogna so we can take some questions that might have come in through the chat.
Thank you so much, Keiko. This was a wonderful workshop, and thank you for taking out time and help build this amazing document, this notebook that the attendees can actually follow, play around with, change the values, and see what could be done. So thank you again, and thank you for the engagement audience. This makes it very enriching experience when you're giving out questions, you're learning and asking the things that need more clarification. So thank you so much again. Keiko will be available to answer a few questions right now, but if we do not answer all the questions, I think she's more than happy to answer them in an email. So I will try to cover as many as I see. I see a lot of questions coming in, so let me start from the top. Okay, I think the first question was, why did you refer to the data frame as a container?
I think I referenced a variable as a container, and I reference it as a container because a variable that's what it is. It contains whatever you tell a variable to contain. So, for example, if we see here that this variable df contains our data set, if I set it, let's save it here in another variable. But if I set df to a value after this, it'll show us that df now contains, this 3 value. So now df is not representing the data frame, but it's representing the value that we told it to represent. So it's really just a container that captures whatever you put inside of it. So that's why I referenced it as a container.
Sounds good, thank you. All right, the next question is, what's the purpose to use Jupyter Notebook versus Jupyter Lab? Is it Anaconda dependent, or what is going to be installed when you do one versus the other?
Sure. So if you install Anaconda, it installs both. I could have opened this in Jupyter Lab. There's not a difference in what you can do in terms of like the notebook construction, but the user interface is different. So the Jupyter Lab will look more like a console. If you've worked with R before, it'll look more like R, where you have kind of the directory to the left, you have kind of the scripting interface, and you have a console. So just the interface is different, and some of the things that you can do are different between the two kind of platforms.
Makes sense. Thank you. All right, the next question is, earlier in the presentation, you mentioned that NaN values are floats. Is that always the case, or is it mostly dependent upon the data type of the value?
It's true that it's always the case. So NaN value is by definition a float. So you should only use them in values or arrays that contain float values.
Makes sense. All right. So I see the next question. I think this was mostly both Pandas and NumPy have been loaded. Do they have different vocabulary that differentiates them between the actions that they can perform? For example, when you use the square brackets to call one of the columns versus when you use a dot to refer to that column, is it different, or how are they similar?
Sure. Yeah, that's a good question. So some basic things like Python things are the same across the two. So the dot notation, the concept of methods and attributes, that's a Python object thing. So it's going to be consistent between the two packages. But in terms of how you extract information, I think they tried to keep it kind of consistent in how they would use the square bracket notation. I'm not an expert on this, but there are differences. Like you could see that in the NumPy arrays, we use the square bracket notation by itself. And with the Pandas series in data frame objects, you have to have the iLog attribute to call on top of that too. So there are some nuances like that between the two packages.
Makes sense. Thank you. All right. We have 2 more minutes. I'm just going to capture two more questions in here. So there's also VS Code and PyCharm other than the Anaconda packages. So what is your opinion on those? Would you recommend one versus the other?
If you have a preference for them, you're of course more than welcome to use those. And I think data scientists use both. It's not one or the other. But what's really nice about Jupyter Notebooks or Jupyter Lab is that whenever you want to run something, the output is immediately available to you in front of you. So it's interactive, right? You can see what you're doing as you're doing it. Whereas if you have, if you're working on a PyCharm or something like that, it takes a little bit longer, or it's a little bit harder to come out at those individual results throughout the notebook.
Absolutely. All right, this is going to be the last question. What is the main difference between, or main difference in the application between an array and a series?
Could you repeat that?
What's the main difference in the application between an array and a series?
Ah, that's a good question. So a series, kind of cover this a little bit more in the third tutorial notebook. But a series really allows you to closely work with a Pandas data frame. So I kind of showed how you can create new columns using Pandas series, because the series is kind of connected to the data frame. So there are other nuances I don't think I can cover in a minute, but they're related, but perform different kind of purposes in the context of working with data.
Absolutely. I have one last question outside the ones that I'm seeing here. Where would you recommend someone who's starting with a data set and start, trying their way into this? Do you recommend any websites or any places or repositories to find good data sets for beginners?
Yeah, absolutely. So if you look at this abundance of resources here, um, I kind of point you to a number of things. You can go through and watch video tutorials. Wiz has a YouTube channel that contains really great resources on how to work with data using different data sources. So you can follow along and do some exploratory analysis with them. Or you can go to the Kaggle page and you can find a whole bunch of data sets that you can download and work on yourself. And on Kaggle, the users on Kaggle will post their code. So you can look through their code to see what they do with the data set, and you can kind of follow along that way too. So there are a whole bunch of really useful resources out there for you, readily available to kind of follow along and try things out on your own with.
Absolutely. Thank you so much again, Keiko. This was a wonderful workshop. This gave a very broad explanation as to how you can start with Jupyter Notebooks, what are the data types, how you can impute missing values. So I think this is very helpful for someone who's getting started, getting their feet wet in this field. So thank you again.